This is an AQA A-level chemistry question. It has got elements of atomic structure, alcohols, and structure determination within it. Pause as you go, seeing how you do, and then you can review your answers later. Here's part A, parts B and C, and finally parts D and E, a total of 10 marks. So let's go back and take a look at the answers. In A, we have got glucose decomposing in the presence of microorganisms to form a range of products, and we're given some percentage values by mass of carbon and hydrogen. But it is a carboxylic acid, so we need to deduce the empirical and molecular formula of the carboxylic acid formed. Now, for empirical formula, I'm always going to recommend the table with the mass, the atomic mass, the number of moles, and the mole ratio. You then need to put the elements along the top. We've got 3 here, carbon and hydrogen, and reading the question carefully, you can see that there will also be the oxygen. I've put the percentages in and you can see where those numbers have come from. I've highlighted those with colour, but it does mean you need to work out the percentage of oxygen. Now the remainder is 54.6. The atomic mass or mass number goes in. Remember, that's the larger of the two numbers. Carbon is 12, hydrogen 1, oxygen 16. And from there I can do M over AR to find my number of moles, 3.41, 4.5 and 3.41. Now to get to the ratio in an empirical formula calculation, what you've got to do is divide those moles by the smallest number. The smallest is 3.41. So I get 1, 1.32 and 1. It's not feasible to have 1.32 as a molar quantity within a formula. We need to get to a whole number or as close to an integer as possible, so that we can round. So the easiest way to get to an integer here is going to be multiply them all by 3. And it takes you to the values 3, 4, 3. So my empirical formula is C3H4O3. But we still need to work out the molecular formula. We've been given information that the MR is 88. Now actually C3H4O3 has an MR of 88. So actually the empirical formula in this circumstance is equal to the molecular formula. They are both C3H4O3. Moving on to part B, ethanol formed by the fermentation of glucose. A student carried out this fermentation reaction in a beaker using an aqueous solution of glucose at a temperature of 25 degrees C in the presence of yeast. Write an equation for the reaction occurring during fermentation. Now this is one of those that you need to be familiar with, that you do need to be able to replicate. Glucose is C6H12O6 and it's breaking down to ethanol and carbon dioxide. Now this is commonly used to make alcohol that people drink. It's also commonly used as a part of the bread making process where the CO2 causes the bread to rise. Still not balanced though, because I've only got 1, 2, 3 carbons, I've only got 1, 2, 3 oxygens, and I've only got 5, 6 hydrogens. So to balance it, I need to put a 2 in front of each of those, and I've now got 6 carbons, 12 hydrogens, and 6 oxygens. In industry, the fermentation is carried out at 35 rather than 25. Why would that be? But also, what disadvantage might there be? Well, the advantage is that ethanol is produced at a faster rate. We're moving into kinetics territory there. Increase in temperature increases rate of reaction. It is important to note on this one that fermentation, if you went too much higher than that, the yeast might be denatured and that would actually stop the reaction happening. But in terms of disadvantages, at higher temperature, you do have greater energy requirements, and that leads to greater costs for that energy. Moving on to part D, the method used by the student in part B would result in the ethanol being contaminated by ethanoic acid. How does this contamination occur? So this takes us into the alcohols topic. And we have got to be aware that alcohol can be oxidized by oxygen in the air. And alcohol can be first oxidized to an aldehyde, but it can go on to be oxidized. If it's a primary alcohol and it goes to an aldehyde, it can go to a carboxylic acid. And that's why you'll often find that alcohol, you think about things like wine, if you leave it open, will turn to vinegar. On to part E, give two differences between the infrared spectrum of a carboxylic acid and that of an alcohol, other than the fingerprint regions. So this is a year 13 topic, structural determination. The two key differences, and you've got this information actually on your data sheet. Alcohol would have a broad OH peak between 3230 and 3550, whereas the acid would have that broad peak at 2.5 to 3000. The other key difference is the fact that a carboxylic acid has a C double bond O bond, and that would be at 1680 to 1750 cm to the -1. The alcohol would not have a peak in that region. That takes us to the end of this question. Thank you for listening.